Hi, and now we are in this again in another session, session 4. So, in the earlier class, we have learned about Coulomb's law, its vector form, and principle of superposition, and we did some simple numericals. For the continuation here, we go with some more numericals. By just practicing the numericals, you will get thorough in the concepts as well. That's the important thing here. You can do the numericals and you will become thorough in the concepts. That is the usage with this practicing numericals. And we'll learn some concepts also here, the concept after this. So here we'll go with the numerical first. This is useful for your board exam and as well as for your competitive based examinations. Look here, three charges Q1, Q2, Q3 are arranged. So like this, as shown in the diagram. So this is x-axis and y-axis. So here Q1 is kept and Q2 separated by distance t, and Q3 and it is separated by a distance d, and Q1 the charge is given, Q2 is charge is given, Q3 charge is given, distance is given, and distance is given in centimeter. So we need to do the problem in SI because we know the value 1 by 4 pi epsilon naught, it is 92 10 to the power of 9 in SI units. So now here the distance between Q1 and Q2 is d, and the distance between Q2 and Q3 is d. Then what is the distance between Q1 and Q3? Just look at this diagram here. It is a right angle triangle and these are the two sides. So it is d and d. This will be equal to root 2b. Okay. So now we are having the distances and okay, given there. And now I want to calculate the resultant force on Q3 here. The resultant force on Q3. So what is the resultant force on Q3? The force by Q1 on Q3 and the force by Q2 on Q3. The force by Q1 and Q3 is F31. It is in this direction. Because these two are like charges, it will be like in this direction, pushed apart. And Q2 and Q3, this is negative and this is positive, unlike, so this will be pulled towards this side. So now it will be in this direction. This is F31 and this is F32. Force on 3 by 1, force on 3 by 2. So like this, after making a diagram like that, now directly we can go for the solving this problem here. So now F31 is 1 by 4 pi epsilon naught Q1 Q3 by r square. What is 1 by 4 pi epsilon naught? It is 9 into 10 to the power of 9, and Q1 is 2.5 into 10 to the power of minus 6 coulombs, and Q3 is 2.5 into 10 to the power of minus 6 coulomb. I need to mention the symbol here. And r square, it is given as root 2d. R is root 2d, so root 2d is 5 into 10 to the power of minus 2 whole square. So just by calculating this, we are going to get the answer as 11.2 Newton. Right, now that is our F31. And coming to this F32, it is 1 by 4 pi epsilon naught Q3 Q2 by r square. So it is 9 into 10 to the power of 9, and Q3 is, what is Q3? It is 2.5 into 10 to the power of minus 6, and Q2 is minus 1, so no need to mention the symbol here. Directly you can write because we are going to find the magnitude. Already we know the direction there. I presented it in the form of an arrow there, so there we can understand it easily. So now 1 into 10 to the power of minus 6 divided by t r square, that is 5 into 10 to the power of minus 2 whole square. And by calculating this, we are going to get the answer as 9 Newton. Okay. Now we got these two values, f31 and f32. After finding this, we are already in your 11th class, you will learn how to solve the two vectors, the resultant of the two vectors, everything using that knowledge here. Now it is, we just represent it like this. Just look at the diagram here. So now your f31 is in this direction and your f32 is in this direction. So now we can't do any work on this now, whether you cannot add them directly. The only thing is, when you can do is, if this is solved into two components, one is the horizontal, other one is the vertical. Already this is on this negative side of x-axis. So you can, after arranging this into horizontal and vertical, then we can add or do the resultant of that. So now f31, dividing this into components, this becomes f31 cos theta, if this is theta, and this becomes f31 sin theta. And if we calculate f31 cos theta, f31 cos theta, what is f31 here? 11.2. What is theta here? If this is 45 and this also will be equal to 45. This is 45, this also will be 45. So what is cos 45? 1 by root 2. 1 by root 2. So 11.2 and 1 by root 2 is 7.9 Newton. And similarly here, f31 sin theta. Automatically, if this is 7.9 Newton, this also will be 7.9 Newton, because here this angle is 45 degree. You can understand. If you do it, it is f31 sin 45. It is, what is the value here? Is sin 45, it is 11.2 into 1 by root 2. The same value you are going to get, 7.9 Newton. So now you are having f31 cos theta in this direction and f31 sin theta in this direction. So what is the resultant along x-axis? So it is fx is equal to, so what is fx here? f32 minus f31. This is in this direction, that is in that direction. So it is f32 minus f31 cos theta. So yeah, what is f32 here? We already got it as 9 Newton. What is f31 cos theta? It is 7.9 Newton. 9 Newton minus 7.9 Newton, it is 1.1 Newton. Now this is the resultant of these two, and now going to fy. It is only one is here, that is f31 sin theta. So that is 7.9 Newton. So now we are having fx and fy. Certainly the resultant will be like this. This is your resultant. So this is your f or f net. So now what is fx? If fx and fy are there, and if they are perpendicular to each other, f is equal to square root of fx square plus fy square. Fx square and fy square, it is square root of 1.1 whole square plus 7.9 whole square. So we are going to get the answer as 7.98 Newton. And if you want to find the angle, very simple here. With how much angle it is making means, let's make it as alpha. And we just see here, what is sin alpha? It is opposite side by what is the sin alpha, tan alpha here, opposite side by adjacent side. So it is effect of y by fx. So here our angle can be found out by tan theta is equal to f y by fx. So it is 7.9 by 1.1. So you can calculate theta is equal to tan inverse of this much, 7.1 like that. So this is how we can solve this problem. So here, just once look at the problem here. We just understood here how the charges are there. and just simply applied the principle of superposition here. We got the two vectors f31 in this direction and f32 in this direction, and using our previous knowledge how to solve the problems in the vectors are there, just resolving this component into horizontal and vertical, and then finding out what is the resultant on x, what is the resultant on y, and if it is fx and fy are there, what is the resultant, and then finding the angle between them. Okay, so like that we can find the magnitude as well as direction. Pause the video and just look at your notes. Okay, here is another problem for you. Three charges Q1, Q2, Q3 are placed on the vertices of an equilateral triangle of side 1 meter. Find the net electric force on charge Q1. Okay, now we have to make the diagram. So this is your equilateral triangle, and here this is Q1, Q2, and this is Q3, and here Q1 is the positive and Q2 is the negative and Q is the positive. So what is the net electric force on this charge Q1? So here, what is the resultant force on this? By 2, Q2 and Q3. So here, between this Q1 and Q2, how the force will be acting? Between Q2 and Q3, this is the force will be in this direction. Okay. Let me name this as some like F1. And between Q1 and Q3, this will be pushed apart. So this will be in this direction. Let me name it as F2. Or else you can write it as F of 1, 2. And this is F1, 3. Whatever you want you can write. So now, understanding this, let us find out what is this F1 and what is this F2. So directly I can go into the problem now. So F1 is 1 by 4 pi epsilon naught, that is 9 into 10 to the power of 9. And it is Q1, this is Q1 and Q2. Q1 is 1 microcoulomb, 1 into 10 to the power of minus 6. Q2 is minus 2 microcoulomb, already told you, didn't mention the sign here, because already we are opposite in the direction. So now it is 2 into 10 to the power of minus 6, and the distance between them is 1 meter, so it is r square, it is 1 square. So 9 into 10 to the power of 9, so the value will be equal to, that is 1.8 into 10 to the power of minus 2 Newton. And similarly, F2. F2 is say 9 into 10 to the power of 9, and what is F2 is between Q1 and Q3. So it is, what is Q1? 1 into 10 to the power of minus 6, and Q3 is 3 into 10 to the power of minus 6 divided by 1 square, and by calculating it, we are going to get it as 2.7 into 10 power minus 2 Newton. You make the calculation once and check it is right or wrong. Okay, and you should have a practice here how to make these calculations. Okay, now this F1 and F2, you just observe here, this is F1 and this is F2, and the angle between them. What is this angle? This is equilateral triangle, as you know. This will be, all the three angles will be equal 60 degrees, and so if this is 60, this will be equal to 120. So we are having F1, F2, and the angle between them is 120. So what is the resultant? Already you know the formula, you have learned it in your 11th class. So F net is square root of F1 square plus F2 square plus 2F1 F2 cos theta. So what is your F1 square? It is 1.8 into 10 power minus 2 whole square. F2 is 2.7 into 10 power minus 2 whole square plus 2 into 1.8 into 10 power minus 2 into 2.7 into 10 power minus 2 and cos theta, cos 120. What is the value of cos 120? It is minus 1 by 2. So it is minus 1 by 2. So by making the calculation, you are going to get it as is 2.38 into 10 to the power of minus 2 Newton. So this is the net resultant force what we are getting. It's F1 and F2. And you can understand that the resultant will be like this. And what is this is the magnitude. And how to find the direction? Very well, here it is. This is what is for finding the resultant, the angle made by the resultant with one vector, with the F1. So the formula for it is is equal to, it is F2 sin theta by F1 plus F2 cos theta. So it is F2 sin theta plus F1 plus F2 cos theta. To substitute the values, the sin theta value, sin it is sin 120, it is 0.87, and cos theta it is minus 1 by 2, already you know, and by calculating that you are going to get it as 1.039. So tan alpha is equal to 1.039. Alpha is equal to tan inverse of 1.039. This is the direction. And it is the angle made with F1. So the magnitude of the resultant is 2.38 in 10 power minus 2 minus 2. You have to put it in the words here. The resultant, what is it? The net electric force on the Q1 is, the magnitude is 2.38 into 10 power minus 2 Newton, and makes an angle of tan inverse of 1.039 with the force of, what is F1? 1.18 10 power minus 2 Newton. That you have to put it in the words. Okay. Pause the video and take this problem. So the first problem we did in one method, and the second problem we did using the vectors method. Observe that carefully. And if you are able to understand how to do a problem in a particular method, and you can find out the better way how you can solve the problem. Depending upon the situation, you can select the method, and here the time factor is very important, and you can solve the problem easily. Similarly, here we are going with another method, the same problem in another method, the easier way, somewhat a different method. But do practice all the methods, because sometimes some are applicable and some are not applicable, and we have to go in an easy way. So here the Q1, Q2, Q3 are taken at the vertices of an equilateral triangle, and here the same thing. Now what is the net force on Q1? And these are the charges. Q1 is 1 microcoulomb, Q2 is minus 2 microcoulomb, Q3 is 3 microcoulomb. And what is the net force on this Q1? So we are going to do the problem by making the coordinates at Q1, Q2 and Q3. Coordinates means x coordinate, y coordinate and z coordinate, because we are having x, y and z axis. So that's why what I'm going to do is I'm just going to fix this Q1 as the origin. So that means this will become your x axis. And this will become your y-axis. So if this is the origin, what are the coordinates of this Q1? It is 0, 0 and 0. And coming to this Q2, what is the distance between Q1 and Q2? It is 1 meter. So now, on x-axis it is 1, on y-axis nothing is there, on z-axis nothing is there, it is 0. So the coordinates are written like that. Then how to make the coordinates of this Q3? So this is your x and this will be your y. So if this is x, what is the length of this? It is half of this. So it is 0.5. So your x coordinate becomes 0.5. And your y coordinate. What is your y coordinate here? This is your y coordinate, isn't it? So if this is your y coordinate, what is this for this triangle? It is altitude of this triangle. So what is the altitude of this triangle? Altitude of this equilateral triangle, it is root 3 by 2a. That is the side of an equilateral triangle. So it is root 3 by 2, the side is 1, so it is simply root 3 by 2. So what is the value of this root 3 by 2? If you calculate, we are going to get it as 0.86666 something else, so you can write it as 0.87. So your y coordinate is 0.87 and your z coordinate is 0. So now, after finding out these coordinates, your problem will become easy to calculate now. So now, what is the force between this Q1 and Q2? So it is F1, and here you have to mention in this method you have to mention these symbols wherever it is kept there. Certainly we should not ignore it. So F1 is 1 by 4 pi epsilon Q1 Q2 by, now we are going to do it in a vector method, so it is R1 minus R2 whole cube. For a cube here there should be a vector R1 minus R2. Now this is 9 into 10 to the power of 9, and Q1 is 1 into 10 to the power of minus 6, and Q2 is minus 2 into 10 to the power of minus 6, and this is the magnitude, right? The magnitude of this vector. So what is the magnitude? It is already given. We need to go for taking these coordinates, finding the length, and then finding out. Directly we can make it as 1 cube, and here R1 minus R2 here. So it is 0 minus 1. I cap 0 minus 0. J cap 0 minus 0. K cap. This is the vector here. This vector is this. So now if you just calculate this, you are going to get it as, so simply this will become minus 1 I cap. So you are going to get this value as this 1.8 into 10 to the power of minus 2. Whole I cap is remaining, so it is into, this is I cap. So it is on this x-axis only. I am coming to this F2. Is 1 by 4 pi epsilon naught. F2 is between Q1 and Q3. So it is Q1, Q3, and it is R1 minus R3 modulus whole cube, and the vector R1 minus R3. So it is 9 into 10 to the power of 9, and Q1 is 1 into 10 to the power of minus 6, and Q3 is 3 into 10 to the power of minus 6. R1 and R3 here, this length is 0 minus 0.5 I cap plus 0 minus 0.87 J cap plus 0 minus 0 K cap. So by just doing this, we are going to get it as minus 0.5 I cap minus 0.87 J cap. Okay, and by solving this, it is this vector here, the magnitude of this R1 R3 is 1, and it is 1 cube. So now the value will be is minus 1.35 cap minus 2.349 cap into 10 power minus 2 Newton. Means we are going to just by calculating this, we are going to get a value, and if you multiply that value with this 0.5, we are going to get it as minus 1.35 cap, and multiplying with this we are going to get it as 2.349 J cap, and this 10 power minus 2 Newton. So here, this is your F1, this is your F1, and this is your F2. What is the resultant here? F is equal to F1 plus F2. So now, directly you can go with the adding of these on adding this I cap and j cap and j cap and k cap and k cap here, because these are already in the vector form. So 1.8 into 10 power minus 2 minus 1.35 to 10 power minus 2. Just add this. That means 1.8 minus 1.35. You are going to get it as 0.45 I cap, and it is this because no j cap here, that remains as minus no j cap here, so 0 j cap minus plus of minus 2.349 j cap, so it remains as okay. Now we have calculated F1 here and F2 here, and we got the two vectors F1 between Q1 and Q2, F2 between Q1 and Q3, and the remaining thing is we have to go and find the resultant, that is F net. It is nothing but F1 and F2. So here this is in the vector form and this is in the vector form. Just what are all on this I, that means x-axis, just add them. We are going to get it as 1.8 in 10 power minus 2 minus 1.35 in 10 power minus 2, it is 1.8 minus 1.35, it is 0.45 I cap, and here there is no j cap, so 0 j cap minus 2.349, that is minus 2.349 j cap, and no z cap here, so that's why no need to mention that. So now you got the vector as 0.45 I cap and 2.9 j cap into 10 power minus 2 Newton. That's the answer finally. And here, if you are representing the vector in the form of this I cap, j cap and k cap, it is not necessary to write up to say what is the magnitude and what is the direction. So this is one way of solving a problem using these coordinates and these vector forms. Okay, so practice the problems, all the methods, and be thorough. Okay, see you in the next session. Take care.